Hi everyone, welcome to the next video. Today we are going to be talking about something that is very cool in cybersecurity, that is called shellcoding. I'm going to be describing what a shellcode really is, and we are going to get started in how to write a basic shellcode in Windows. So very excited about this video. Let's get started. So what exactly is shellcode? So shellcode differs from a normal program in different ways. A normal program executes itself in a structured format, while shellcode doesn't necessarily do that. Why is that though? Like in terms of you performing a shellcode action in an application, so there is a vulnerability in an application and you're exploiting it and you're sending in your shellcode, the payload will actually be calling locations based on specific memory addresses rather than how a normal program would compile and run. So you are actually running everything in memory and trying to get the details out. So that is how shellcode differs from a normal program. Um, Now we are going to see how shellcode actually look like. So you might have seen, like, people putting in shellcode randomly in exploits, but how does it, if if you're really writing a program and then extracting a shellcode out of it, how will it actually look like? So let's actually try to build that. In Windows specifically, how you write, there are different variations on how you can write the shellcode, but here I'm trying a very basic thing. The aim here uh, is to dynamically go till a DLL called kernel32, and from there we are trying to load a function called winexec and run whichever application that we want from it. That is the idea here. Now how are we gonna get till there? So this image that you're seeing right here is actually something called, it's not something, it's how you actually get to the kernel32 DLL. Um, in Windows, you have something called thread environment block, then the process environment block. The thread environment block actually gives details about the threads that are all there in the system. In the thread environment block, what we are specifically going is for a file segment. That is a file segment at the address 0x30, x value 0x30. Why are we going here? The reason we are going here is that we cannot do much specifically from the thread details itself. We need to, our aim is to get till a DLL, and inside the DLL to call a function. So dynamically we need to go till there, and the way you go from there is to first go from the thread environment block to the process environment block, which contains details of all the processes in the system, the DLLs, and things like that. So from the thread environment block, you're going to file segment 0x30, that is pointing to the process environment block. As you can see here, maybe I can zoom in a bit more. Yeah. So in the process environment block, you have a lot of details, but specifically in that, what we are trying to do is to go with the process environment blocks LDR data or loader data. Uh, Now you might ask, what is this loader data and what all are contained in the loader data? Loader data basically contains three linked lists that you can see here. There is an in-load load order module list, and then there is an in-memory order module list, and then there is an initialization order module list. The first and last are not really important because we are trying to dynamically get information out of this. But we are really looking into the details in the in-memory order module list. And if you go into the in-memory module list at the address 0x14, you can directly go into the LDR module, which contains, okay, this is basically showing what all are contained in the LDR module. And LDR module contains details of the DLLs and other details. So that is exactly where we want to be here. We go to the LDR module and to the address 0x8 of it. So understand that this is basically the same. This is a linked list. So as you know, in a linked list, you have the first thing that is the pointer to the next location and the data. So you are in the first linked list at this address, and from there you're trying to go to the next linked list and the one after that. So this is basically you're trying to traverse two linked lists here. So you will be here, you will be traversing, your head will be here. You're trying to go to the next linked list that is in the LDR module, and to the next one, and to the next, and finally to the after that. So that is basically three hops instead of two. So you will reach till the NTL DLL and finally till the kernel32 DLL. So we're gonna be just doing only this much in this video. In the next video, we will try to go into the functions and how you can find the function that you need and try to call maybe a notepad or calculator from it. In order to do this, what I'm going to do is something called using a flat disassembler. Uh, this has been well known, well used from a long period of time. I think it was developed in 1999 or something. Initially, what are we going to do? We are going to solve EBX to EBX. The reason we are using EBS is because if you are using any system calls or anything, EBX won't get overwritten. So it's a great way to store our pointers. So we're going to store it. The reason we are storing it, whenever you store a value with itself, it becomes 0. So we know for sure that there is nothing in EBX. Then we're going to move EAX to the file segment register 0x30. If we are correct, we can just check it here again. That is 0x30, which points to the process environment block plus the address of EBX. I'll be doing a lot of dereferencing here because symbol move functions and LEA function, LEA load effector address um, functionalities will be a 2 byte instruction. We don't want any null characters in our shellcode. So that is why we will be doing a lot of dereferencing here. Next thing here is the reason why we don't want null characters is because it will basically prevent the shellcode from executing. We don't want any null characters in our shellcode. Okay, next thing, now we have this address in EAX, right? What do we do next? Now we are here exactly at the process environment block. Then we need to go to the uh, process environment blocks LDR data. So that is at 0x0c. So that will be EAX plus 0x0c. Now we are exactly here, or which is actually pointing to the PBR loader data. In the PBR loader data, you want to go into the in-memory module linked list. So these are three linked lists that are here. We want to go into this particular one. So that is, we want to go into the address 0x14, right? Okay. These are all not necessary. EX, comma, EX plus 0x14, if I'm right. Um, Yeah, we are now in the in-memory module list. Now from here we need to dereference it 2 times because the initial pointing will be here, then we'll be pointing it to here, and then we will reach basically the kernel. Sounds good. Okay, now we are here. We need to dereference EAX 2 times. So we are going to put the value in EBX, dereferencing once. Then we are going to move the same value into EBX. Now we have reached till the kernel32 DLL, which is right now we are at the in-memory module list at 0x8. Now from here, what we need to do is that we need to move to the base address of the kernel32. That is to here, or specifically the 0x18 PVOID base address. So now currently we are at 0x08. So how you do it is at 0x1c minus 18 minus 0x8, which leaves to 0x10. So you can just do that. Move EAX to EAX plus 0x 10. Uh, to be correct, let's do hex calculator. Can we do the calculator here? 0x08 0x. What is the address here? That is 0x18. Just to make sure that I'm correct, and we're going to subtract 0x08 from it if I'm right. Yeah, see, it's actually correct. So hex value is 10. We are trying to move into that. Okay, now what we are just going to do is that we are just going to compile this. Okay, right field, it's because I'm using something called an X32 debugger. Okay, what am I using here? You might not know it. So there is something called WinDBG, which you use for debugging programs. That is this one. So I'm using the X32 version of it because I'm writing an X32 program. And this is the compile program that we have right here. I want you to be looking at the values of the registers. So once we start, now we are at the initial XORing. So now we have XORed it. EBX has basically become 0. We are moving down. We are at NTDLL is being invoked. See, now we have reached to kernel32's base address. So that is it for this video, where we are reaching till kernel32. In the next video, we are going to be really going into finding specific function kernel32 and using that to run a notepad or calculator or any other application that we want to run. So this is the first part of the shellcoding tutorial. I hope you liked it. This is very basic stuff. There is a lot of details of how to write shellcode available on the internet. You can just go through it and understand it yourself. I hope you like this part. If you have any doubts, please do comment below. Thank you so much for watching.